Okay, this one can be wicked, solving various forms of equations. Now you have x second plus 8 equals 6x. Before you start going, you have to identify the structure of the variable, okay? It's to the second power, it's to the first power. So you got the same variable, it's to essentially two different powers. So that's when you have to use your factoring properties. So here's factoring properties. How many answers we got? Well, 2, because x is second. Equals 0. Ooh, we don't have the 0, so what we need to do is put that up there and minus that 6x out of there. Now we got 1x second and 8, but no x. Okay, so we hang out the 6. Now you put your equals 0, and you got to write this in the appropriate order. We start with x to the second, then x, then the constant. So x second's going to have a 1, x is going to be negative 6, and then the constant's going to be 8. And now we're equal to 0. Now we count the number of terms we have. 1, 2, 3. So that's 3 terms. That's trinomial. So that's GCF followed by the t-chart. So x on the end, nope. Negative in front, nope. 1, 6, and a to be 1. So then A, B, C. So 1 times 8 is 8. It's positive. Okay, so the signs have to match here. And they have to add to the B term, which is negative 6. Okay, so they'll probably stay double negative. So 8 divided by 1 is 8. That's negative 9. 8 divided by 2 is 4. And there's your negative 6. Okay, a is 1x to the second power. So negative 2, negative 4. Then x to the second is x times x. And then we put 1, 1. Now 1 and 2, you can only divide that by 2. And then 1 and 4, you can only divide that by 1. Okay, divide by 1 is all you can do. So really you wouldn't even need to divide by 1 because you know the identity property just keeps it the same. Okay, so those are your factors. We have 1x minus 2 times 1x minus 4. So F1, F2. So we really don't need a multiplier of 1. That's kind of pointless because dividing by 1 is just going to keep it. So x would equal 2 for the first answer. And then get rid of the 1 multiplier. If it's not a 1 multiplier, you'd obviously need to keep it and divide, but 4 divided by 1 would just be 4. So 2 and 4. Okay, next problem, we have x to the third power plus 6x to the second power minus 9x minus 54 equals 0. So you have x to the third, x to the second, x, and the constant. So obviously these are same variable, different powers, so you're going to use your factoring properties to solve. Okay, so x third means there would be 3 solutions. So the zeros here, so you have 1, 2, 3, 4 terms. So that's a quadnomial, okay? So grouping, and then the same thing with the GCF lines factored out of each binomial. And then little parentheses, big parentheses, okay? Okay, so we put 1x to the third plus 6x to the second. Then we put the negative 9x with the minus 54. Okay, so we have to factor out x to the second. You have x third, x second. You factor out the x to the second. That can be factored from both the terms. No negative 1 and 6 is 1. Then, no x. You don't factor out x here because this is a constant. It doesn't have it's not multiplied by a factor of x. You have a negative in front here. then 9 and 54. There's 9, there's 54. They're in row 9. Okay, so we'll be dividing by 1x to the second here, and we will dividing by -1 here. So that's 1 x third x second. We have an x remainder, and then 6 x second divided by x second. That's a complete wipeout. And then -9 divided by -9 is 1 with an x remainder. -454 divided by -9 is +6. So we have 1x plus 6 within inside each of our two parentheses. So since that's the same, we would put 1x plus 6 here. And in the second one, I would put my 1x second with my -9. I don't like writing plus negative. I just like writing -9. So take the 1s off the front of the x's if those are 1s, okay, because you don't need them. X plus 6. But then this is a difference of perfect squares. D difference means you need positive, negative, and you have that, okay? Now, are these perfect squares? Well, x to the second certainly is, because that can be written as x times the variable x times itself. 9 definitely is a perfect square, because that can be written as the value 3 times 3. So x3, x3. So we don't put this, we want to replace this with x plus 3 times x minus 3. So F1, F2, F3. So x plus 6 equals 0, x plus 3 equals 0, x minus 3 equals 0. So minus 6, you get -6. Minus 3, you get -3. Plus 3, you get +3. Okay, our next problem, we have 3x to the second power minus 2 equals 52. So, I have x to the second, but that's the only power I have x. X to the second only. So that is when we don't factor. We want to apply linear properties. Okay, so linear properties. Fill out how many answers there are. 2 of them. Collect the x terms if there's more than one, but there's only that x term there. Now we solve. By solve, I mean get rid of the operations on the x side. So you got times second power minus 2. So circular times. First you're going to plus 2. This is what solve means. Then you take out the times 3 with divide by 3. Then you take out the second power with your square root. Okay? So plus 2. That's 54. And you divide by 3. That's 9. When you solve, it's like the please excuse my dear Aunt Sally backwards. Okay, add subtract comes first, then multiply divide, then exponents and so forth. So positive or negative, and 9's a perfect square. It's 3, but it could be 3 or -3. So 3, -3. Okay, next problem. 45x to the second equals 10x. So you have x to the second with x again when you look through that equation. So to solve it, you need to go back to your factoring properties. So there's 2 answers. Equals 0. So take out your 10x. Then put that in the hangout zone because that can't be combined. That doesn't go with 45 because that's multiplied by x second. The 10 is just multiplied by x, so you can't put those together. So equals 0. Then you got x second, x. You can write your constant if you want, but you know what's going to happen to it because you have 45. You got -10, but you don't have a constant, so that's just deleted. Okay. So now how many terms is that now? That's 2. So you have 2 terms. That's a binomial. So you find out your greatest common factor in the terms of the binomial. Then you see if you can do a difference of perfect squares. Well, x is on the end now because we took out the constant, so we factor out x. We don't factor out the negative because we don't have the negative in the front. Then 10 and 45 wouldn't be 10, but 10 and 45 would be 5. So 5x is factored out. Okay, so 45 divided by 5 is 9. X second divided by x. That's a remainder of x. Negative 10 divided by 5 is negative 2. And the x divided by the x is a wipe. Okay, so put your GCF 5x right there. Now you got positive and negative, so it's definitely a difference, but 9's a perfect square. That's 3 by 3, but the x that's attached to the 9 is not to the second power. Okay, so you write no. So you're just going to write the quantity 9x minus 2, and that's how we're going to get our two answers. So F1, F2. So 5x, here I'll go up here, 5x could equal 0, 9x minus 2 could equal 0. So I would divide by 5 here and I would get 0. I got times 9 minus 2, so we'd plus 2. So 9 times x equals 2. Then we would divide by 9. You get that. From now on, if you get a repeating decimal, I just want you to keep it in fraction form as 2 over 9. Just keep it as 2 divided by 9, which is a fraction 2/9. Okay, next problem. 3x minus 4 equals 5x plus 12. So I have x to the first, and then x to the first again. So this is only, okay? The only power x has in the equation is a first power, so that's an only. And you apply linear properties, not factoring properties, okay? So linear properties, you put how many answers you are. There's only one to this one because x is just to the first power. You collect the x terms if you have more than one. Well, we got more than one of them, but they're to the same power, so you can combine them. They're not on the same side, they're on opposite sides, so take out one of them. I'm going to take out this smaller one, the 3x, by subtracting it. So we have negative 4 equals 2x plus 12. Okay, now solve it. So you got multiplication by 2, no power, and plus 12. So you need to take out the plus 12 with minus 12. And then you need to take out your times 2 with the divide by 2. We will not be doing the square root because the x is not to the second power. Negative 4 minus 12 is negative 16. 2 times x. Divide by 2. Negative 8 equals x. Okay, 6x to the second power minus 5x minus 6 equals 0. So we have x to the second and x, so that is factoring properties. So there are two answers. Zero's there, you can check it, so there's 3 terms. So 3 terms, GCFT table. So no x on the end, no negative. 6 and 5 would just be 1. Okay. A, B, C. 6 times negative 6 is negative 36. Okay. So that's a mismatch. And it's got to add to negative 5. Add those, negative 35. 36 divided by 2 is 18, that's negative 16. 36 divided by 3 is 12, that's negative 9. You're still too wide, so you need to keep dividing. See, because 36 divided by 4 is 9. That's negative 5. Okay, we have it. Now a is 6x to the second power. So you put in your mystery, guys, the positive 4, the negative 9. Then x seconds, x times x. And then you place your 6 in front of it. Okay, so 6 and 4, those are both in the second row, so you would divide here by 2. And then 6 and 9 are both in the third row, so you divide by 3. So it's 3x plus 2, and this is 2x minus 3. So those are your factors. You're going to put 3x plus 2 times 2x minus 3 equals 0. Because look here, 3 times 2 is 6. Bingo. 2 times negative 3 is negative 6, and that always has to be the case when you factor. So F1, F2. So the roots times 3 plus 2, so we subtract 2, and we get negative 2. Now we divide by 3. Negative 2 divided by 3, if you get a never-ending decimal, you just keep it as negative 2 divided by 3, just negative 2/3 the fraction. Now over here, plus 3, plus 3. Now 3 divided by 2 is 1.5. That's an okay decimal because that at least ends. That's an exact decimal. So 1.5. You could put 3 over 2 or 1.5 if you want, but it's going to be up to you. Now we get into some where we have a parentheses. Now parentheses work a little different. Okay, I'm not ever really going to use factoring properties with these. Well, I don't want to say never. Okay. So first, you'll know how many answers you're going to put here, okay? So what we know about x is it's in a parentheses here, okay, with a minus 3. There's no power outside, so there's just going to be one answer, okay? So one answer, we just use the distributive property like old times. So it's going to be 4x minus 12, or plus negative 12, doesn't matter, equals 48. Now you solve. You have times 4, negative 12. So you need to add 12 to both sides, and that takes me to 60. And then you divide each side by 4, and that takes you to 15. So there's your answer. Now in the next one, we have a quantity x minus 4, but it's to the second power. Okay, so that's going to be 2 answers, and that second power you can't distribute. You need to write that you're blocked, and you're going to replace that with h. Okay, we're still solving for x, but for now we're just going to replace that second that x minus 4 quantity with h. So we're going to have h. It's going to be multiplied by 5. It's going to be to the second power. It's going to have a plus 7. It's going to equal 57. Now, after you have shortened that equation, you got to remember that you're going to bring back your x minus 4 on that table on 2 sides. And the reason why there's going to be 2 sides is because look at this, okay? Looky here, and I'll write it here. I use linear properties to solve for the h, okay? So I've got times second power and then plus 7. So we're going to minus 7. We are going to divide by 5, and we are going to do the square root. But once I get the 2 answers, those are your answers for h. You got to bring them to your table. So minus 7, that takes you to 50. Then divide by 5. That's 10. Now, we find the square root of 10. That's not 5. The square root of 10 is irrational. See, I don't see 10 as a perfect square. That's 3.16. Remember, those are your answers for h. Those are what the x minus 4 is equal to. So to find the actual x values, you put your 3.16 here and your negative over there, because remember, it could be positive or negative, and then you solve. So plus 4, you get 7.16. There's your first answer. And then you plus 4, and negative 3.16 plus 4 is going to be 0.84. Okay. Next up, x to the second power plus 9x equals negative 20. So I see x to the second. I've also see we have x. So again, that's factoring properties. There's no parentheses to worry about. So there's two answers. Okay, factoring properties, you got to get your 0. So I want 0 here plus your 20. Now, 20 can't be added to 1x to the second. It can't be added to the 9x, so we hang that up. So equals 0. Then x to the second, x, and a constant. So 1 is my x second, 9 is my x, and now positive 20 is my constant. It's no longer negative 20. Now I see there's 3 terms, so it's GCF table. No x, no negative, 1, 9, 20 is 1. Okay? So ABC, and I evaluate the AC product, and that's going to be 20 positive, so it's a match. And we have to add to get to positive 9. They have to match. Now they could become double positives, but they have to match. So 20 divided by 1 is 20, that's negative 21. 20 divided by 2 is 10, and that's negative 12. 20 divided by 3 is a decimal. 20 divided by 4 is 5. So add those. Okay, that's the right pair. You stop dividing because that adds to negative 9. We just need to add to positive 9, which we'll do if I go positive, positive. So now your A is 1x to the second power. Okay, so x times x, and then you place the 1's in front. 1 and 4, you would only be able to divide by 1, and then you'd only divide by 1. So 1x plus 4, 1x plus 5. Okay, so we have 1x plus 4 times 1x plus 5 equals 0. Okay, so 1x plus 4 could equal 0, or 1x plus 5 could equal 0. So take out your times 1 minus 4, and you get negative 4. Minus 5, and you get negative 5. Okay, number 2. 7x to the second power minus 30x plus 8 equals 0. So in this one we have x to the second and x. Again, that's factoring properties. So there's 2 answers. 0's there, so you check that off, and now that's 3 terms. So GCF table. X on the end, nope. Negative in front, nope. 7, 30, and 8 is 1. Seven times 8 is 56 positive. Okay, so that's a match. We got to make this add the factors to negative 30. So 56 divided by 1 is 56. That's negative 57. That's too wide. 2 and 28. So I add those and we get negative 30. Bingo. Okay. So A is 7x to the second power. So So you put in your -2, your -28. We know we're going to go x times x, but now we apply the coefficient of 7 in front of the x's. Now 7 and 2 would only be divisible by 1, okay? But the 7 and the 28 are divisible by 7. So we're going to keep that as 7x minus 2. That's going to be 1x minus 4. So let's check this out. 7 times 1 is 7, bingo. -2 times -4 is positive 8, bingo. So we've got 7x minus 2 times 1x minus 4 equals 0. Okay, so 7x minus 2 equals 0, 1x minus 4 equals 0. So we add 2 and we get 2. Divide by 7. Okay, 2 divided by 7. Now, that's, I don't want that. Just put 2 over 7. 2 sevenths. Now over here you got times 1. You can take out the times 1 and just plus your 4, and that's 4. Okay. Okay, 3x to the second power minus 15x equals 0. So I have x second and I've got x. Obviously you're going to use factoring properties here. So there's 2 answers. Zeros here. There's 2 terms, so that's factoring the binomial. GCF DOPS. Okay, so x on the end, yes. Negative in front, nope. Then 3 and 15 would be 3. So we're factoring out 3x. So it's 1x, negative 15 divided by 3 is negative 5, and then x divided by x is a cancel. So you bring your 3x over here. Now, is this a different? Does this represent a difference of perfect squares? Well, you got a positive and a negative, so it's difference. But is it of perfect squares? Well, 1 is a perfect square. That's 1 times 1. X would have to be to the second power to be a perfect square, so you write no. Okay, so we're just going to keep that as 1x minus 5. So F1, F2. So 3x could equal 0, or 1x minus 5 could equal 0. So I would divide by 3 here, and that would be 0. I really don't need the times 1, it's just add 5. That's 5. 0 and 5. Okay, last problem. 3x to the second power minus 5 equals 145. So in this problem you have x to the second, and that's it. That's the only power the x is ever to, is the second power. So we're not factoring, we're using the linear properties. Okay, how many answers? There's still 2. Collect the x terms if you have more than 1. We just have the 1. Now you solve. I put solve, that's what it means. You need to get your x by itself. So you got times a second power minus 5. So we take out the minus 5 first with plus 5. Then we do have multiplication, so we divide by 3, and you get rid of your second power with a square root. So we do those 3 things, and we'll be there. So 145 plus 5 is 150. Then I divide by 3. So x to the second equals 50. Now I find the square root of 50. It's not 25. 50 is not a perfect square, so we can expect to get an irrational decimal. Okay, 7.07.